So I kind of want to go through this whole live monitoring situation right now and take a poke at my different systems. So let me start off with the PuTTY. So I have no idea what the systems are doing yet. Let me just see if I can ping them. That one's pingable. That one's pingable. And again, they're all in the same subnet, so I don't expect much problem. When I was looking earlier, I was having trouble logging in. So let me just start by logging into Floyd 1. That came back quickly. So let me just poke around and see what we got going here. I'm just going to type in a SAR, get a baseline reference. And basically, since midnight, it's been stuck in system time. No real IO8, nothing else going on there. We did have something at 8:50 this morning that actually had a spike to it. I want to plot this data later. That's CPU. I'm going to look at memory. It's at 89%. Let me just see what it was for the whole since midnight. So memory's been pretty well used, 96% here. Again, I've got a 128 gig machine. It looks like my cached was 88 gig. So there are things missing in there, and only 57 meg here. We'll talk about commit later, but that's irrelevant. We can overcommit machine. For IRIX people, virtual swap is on here, and that's why we get an out-of-memory killer. So the KB commit is a worthless field to have on that particular report. 96, 96, I'm just looking here. And then somewhere around 8:50, probably when I logged in and started doing things, at 9:20, there was a little bit of a memory trim, and it looks like it was in the cached field. Unfortunately, this does not break out my cached field or my meminfo in more detail like I would like. I'm going to do a SAR-S for swap, and swap has been 100% used the whole time. There's also something called swap cached. This is data that's both in memory cache and out on the swap device. The idea here is I run out of memory, so I do it swap. Then when the program needs what's out on swap, it comes back in, but we leave what's out on swap. That way, if I don't change the page and trim it and throw it away, I don't have to go back to the swap device again. So it's meant to reduce swap outs. A lot of times that swap CAD might be shared memory or SHMEM. I'm just noticing the swap free actually, we had a little bit of swap free until 9:20, and then some sort of memory event actually further filled up the swap at the same time that we tried to do a trim. Because remember in the other report at 9:20, 9:30, wrong one, I can't go back that far. Right here, 9:20 to 9:30 is where we actually see a trim, where the page cache actually went down at the same time. So I'm kind of correlating events here. So not too healthy. We don't know how memory is, but swap is 100% full. This gives me the potential of out-of-memory killers. But again, I don't know what is in memory that's available or reclaimable. When we reclaim or get memory back, that does not bring things back in from swap. We only bring the stuff back in from swap when we need it, when we reference it. It's called demand paging. I'm not going to deal with the page until I demand it. So memory's not too healthy. Swap doesn't look too healthy. We'll look at that more closely. SAR-DP. I kind of like to grep for average. And let me try to get this display wider so that I can avoid some line wraps here. And I only got 2 drives here. SDA appears to be the main one here. This is the average for the day. Let me do a head here. Oops. So I'm looking at transactions per second, number of reads, number of writes. Looks like it's writing more than reading. Average request size. Again, the queue size, nothing's waiting. And my average wait is less than 60, so I'm happy with that. My service time, that, by the way, was 8 milliseconds. 1 millisecond for my service time, and hardly busy. So the disk drives look healthy right now. Let me just do a SAR-DP since midnight instead of the average. And I'm just looking at these last 2 columns here to see if they get real high, and also this percent utilization. And I'm not seeing anything really standing out here. Utilizations are all less than 1%. The wait times do get into the 10 to 20 milliseconds, but not too bad. So the disk drives kind of look healthy right now. Again, SAR 1-5 is still showing system time. I'm going to look at that more closely. So I've looked at CPU, memory, disk. Now the file system buffer cache. And the only way I can do that is, number 1, the proc meminfo. So I'm going to do a cat on /proc/meminfo. You can do a watch on it, things like that. So again, what do we got here? 13 gig free, so I do have some memory free. That's not too bad. I do want to see it on a per node basis because some of my key nodes might be out of memory. 58 meg of raw I/O, not bad. Cached, 8 gig, not too bad. Again, I got 133 gig here that I'm trying to account for. That's only 8 gig of it. Most of this is inactive. In fact, most of it is inactive process space, anon. And that makes me think IPCS and SHMEM. And when I go down here, SHMEM is at 8 gig. So I have 8 gig of SHMEM. And mapped is 0, so this is unattached SHMEM. Mapped is only at 15 meg. So this looks like unattached shared memory segments. But again, I do have to be careful about ls dev SHMEM for files that are open. This is only for shemctl system call IPC attaches. And this is for both. However, I do see a problem here. 96 gig of my memory is the slab. 77 gig of that is reclaimable. And I don't see any NFS traffic right now. So looking at memory, I'm going to do a slabtop -S-C to sort by the cache size. Since it's a big cache, slabtop's going to take a little bit to pop up. And again, this is what we were seeing earlier in the week. 74 gig of that are inodes. And then we've got this XFS ILI, which is another 16 gig, and another 2 gig of directory entries, and some 64-byte stuff, XFS buffers, and then it pretty much drops off at that point. If I don't put the SC, it sorts by this field. But I want to sort by the size of that, how much memory that structure is taking in the slab. So it looks like I got XFS inodes in the slab. Oh, taking a little bit to break out of there. There we go. There's a little bit of a stutter there. Oh, I don't think I have anything installed here. Oh, I do have slabtop. Good. Let me put in the -W and an I. Just seeing if I can catch anything. So I do see a CPU wait time. There were 30 seconds in that slabtop waiting on a CPU. No IO wait, no trim wait. So I was up about 60 seconds, but I was in it running live for a while. But of that 60 seconds, 30 seconds of that was just waiting for a CPU and hardly any real user CPU time. There's also going to be metadata weight and things like that that are not counted in the I/O weight. This block I/O weight is for data, not for metadata. Okay, so looking at my memory, most of it is slab, but I also want to go back now, cat/proc meminfo, and I do see a large shmem here. So I'm going to do an IPCS-AM, and I do have a 9 gig unattached shared memory segment. And that is what this is here, the inactive anon. And that's the same thing that's here. Doesn't look like I have anything in dev shmem, ls-l on dev shmem. Oh, I do have a file in there too. Another 9 gig there. Oh, wait a second. 9 gig plus this. I was expecting shmem to be bigger. It's only counting one of those right now. Okay. The 8107. Can't really tell which one it is. Just because this is showing 9 gig, though, does not mean that that is actually allocated. So I do have 8 gig in this file, but this 9 gig doesn't necessarily mean that that is truly allocated. That was what was requested. I'm going to try to narrow that down and prove that later when I remove this file, but I'm not there yet. I want to finish this analysis. The other thing I should check, though, LSOF, let's grep for dev shmem, or we could grep for big file, LSOF, type grep big file. Nothing has that thing open. Let me do something else here. I'm just going to put that in the background and do my LSOF. And there I can see the DD command actually had that file open. Okay, and now that that thing ran, let's see, cat/proc/meminfo. So now I'm up to a 14 gig shmem. And a 14 gig cached. So this cache field includes the dirty, which is nothing, the write back, which is nothing, the NFS unstable, which is nothing. It does include the shmem, which is the majority of the cache right now. And that's pretty much it. And you can see that most of that is still inactive anon, that 13 gig. Okay, so CPU memory disk, inter-process communication, and now I should take a look at link stat and network statistics, or I mean NumaLink statistics. Link stat-uv, 1-5, let's just take a sample. Oops, interesting. We'll do a -A. And notice I do have some traffic going on here, but we don't have a baseline of where that typically should be. We were under 100 megabytes on the other system. So there is traffic going across the interconnect. Again, you can usually correlate. So B00 to B10, here's B10 to B0. So this number and this number are the same port, or the same link. And then this one, receive B01, B11, B11, this one right here. So that 370 is this one right here. And I'm not seeing any errors or anything like that going on over here. So I do have some rather high, I don't want to say high really, but I do have abnormal NumaLink traffic. But again, I don't have a baseline to be able to see what this thing's been doing for the past week. PCP hopefully is going to plot it. ps-ef, let's grep for PM logger. We do have PM logger running. It's running the config stuff. Let me take a look at that UV statistics later, but that only started this morning, if I remember correctly. We don't have since Friday for this traffic. Okay, I'm going to go back to SAR 1-5. I do still have high system time. I'm going to do a top sys and find out what that process is causing that system time. K-worker threads are basically interrupt handler threads. They come and go. Notice they have PIDs that change. Looks like code 5 is in there. Oh, I see some other things in here. This indicates metadata. This indicates journaling type of activity. AIL, action item list, is where the journal activity has made it to the disk, but the metadata changes itself have not been flushed yet. They have different flush rates. And I'm just kind of looking here. I do see a majority of my system time being a K-swap D. These things have the biggest CPU time on them. And then I've got all these code 5s in here as well. Look at the system time on this AIL action item list for SDB. Let me bring up top at this point. So I've got 13 running. Again, they'll have an R in front of them. 1233 sleeping. I'm not going to change your display permanently, but I'm going to go into F and do a Y to get WChan, and I do want a J to get the CPU they're on. I'm going to go back and get rid of priority because I don't need that space. But I'm not going to save it. And I'm going to do an I to get rid of everything else. And I can see that a majority of these processes appear to be sleeping in an xlog_wait. And that will get counted in the load average. These are waiting on metadata activity. This is a metadata intensive situation. So now to look at that system time in more detail, we're going to do a perf top. Let me do it on a PID. Let me just pick 22343. I'm just going to pick the first code 5 here and see if I can catch anything. Again, this thing is typically sleeping. I'm not seeing any CPU time associated with that process at this point. Let me try a perf top system-wide. And now I can see the main thing I have here is this raw spin lock. But I don't know what that is. This is where I'm spending my time, but not how I got to it. Some sort of iGrab, which might be inode related. XFS sync inode data, another raw spin lock. This is for interrupts. Looks like it found a place for an inode. These look like they're inode related to find where to allocate things. Never seen note interrupt before. At that point, I'm pretty much past everything. So it looks like the majority of my time is right in here. Now, ps-e, let's grep for K-swap. I'm just curious about this 141. Let's see if we have debug info loaded. crash/boot/vm/gz. Waiting a little bit. Again, it's metadata intensive. This thing is probably sleeping on some sort of metadata event. I could have done a echo T into proc sysrq trigger to look at that more closely. And again, I had debug info loaded to give me this system map. Still waiting for crash to finish. There we are. PS grep K-swap. So I'm going to do a BT on 141 and see if we can catch anything. And we're not catching anything there. Basically, this K-swap D is asleep. See if we can catch any of the others. Oops. Waiting for my prompt to come back. Now again, K-swap is only showing things that are sleeping. So these things are basically sleeping, waiting to get woke up by a clock tick or a scheduler. And I am having an event here. So I can go, let me get out of here for a second. I'm going to pipe this into TEE and call this crash hang. Don't know what's happening yet. And now anything that I do on that console, UVCon --clear --no cache P1, hit enter. Oh, I missed it now. So I wasn't able to catch that event. I was a little bit too slow there, but I kind of wanted to get into a traceback or something. Let me quit out of there. I'm not seeing anything in a sleep situation. CSA com on -n crash -w. So in that case, it looks like I had 22 seconds of IO wait on crash. I'm not seeing any CPU wait really. And again, it's not counting metadata wait. We can't see that sort of thing. It did use 87 seconds of user time too, 87, 90. There's still about 50 seconds in elapse. But again, I was sitting there at a prompt, not doing anything, waiting. I'm not sure that I can catch that. In order to try to catch this in the future, I can't get pmchart working on my workstation yet. I don't have admin permissions and stuff like that. But let me go, to Vnc Viewer. So I'm going to get pmchart going here. I don't know if this is required or not. I'm not going to worry about that problem right now. Let's see if we can get this working, though. I'm going to have to drop an xorg.conf file in on things. Again, the load may be affecting me here.
I have not been able to get Vnc Viewer to work on that machine.
Okay. Let's see. I'll take a look at that during break, too, and drop in a different x11.conf file. And I'm not sure, I've been seeing this occasionally, too, and I'm not sure what the problem is there. Okay, I'm going to do something else since that's not going to get me a remote desktop. Let me go to the pmg-server and get a remote desktop. So instead of trying to run it on this system under test, I'm going to try to run it here. So I have to have pmcd running on that system, but I'm going to do a pmchart-h Floyd1. Sometimes pmcd, ooh, this is the old, I'm sorry, this is the old pmchart too. completely different interface. It's the older IRIX version. So let me just see if I can catch anything here. I'm going to go to CPU. Actually, there's a view here. Let me try that one from a prior class. Again, notice when I click in, oh, you can't really tell here. When you click in these, a box goes around it. I'm just going to delete that. Start. So I got CPU, I got memory, I got disk, and I got swap. We see all of the swap full. Again, this is not as good a view as what I was getting before. I can see most of my memory is the slab. I'm going to try this differently. I don't want to use the old one. I don't like that one anymore. Let me go to my system. I did do a reboot. I'm running a newer kernel there. Waiting for it to catch up. There we are. So again, I was looking at raw data from the ASCII tools. Now I want to get into a graphical interface. So first of all, I'm going to do a pmgsys. And I can see two CPUs being pounded with system time. All the other CPUs seem to be idle. If you remember yesterday, these things seem to have affinity just to the first socket of the system. Now I'm going to right-click in there and quit out of there. This time I'm going to do a pmgsys-V and pipe it into TEE and then call it, I don't care, PMG. And now when it writes, it's going to write all of this scene information out. This is the file that creates the scene. And at the top it says this is the pmgsys tool. It shows me my key actions if I click in things, even firing off growth view or growth top from IRIX days. And then for each one of the displays, this is how they're being put together. So I've gone into sites and actually modified these and ordered them by rack and stuff like that to put them in a physical order rather than a logical order. This will also save time in generating if I don't have to generate that scene every time. Let me try mpvis. So this is the 3D scene. Again, I can put my hand in there and rotate and look at it from a different angle to see something that might be of interest. It is interesting to see I've got some time right there. I'm going to click. Oh, and it's gone. I don't have it anymore. Huh. Let me try this. There it is. And I'm wondering if that has anything to do with the interactive GUI that I have going right now. Because there's going to be a lot more interrupts as it's poking and listening for my mouse or my hand there to go. I clicked back and it went away. I just found a correlating effect. So I can see where the interrupts are coming in. Let me do that again. I haven't done any clicking in there yet. Click now. It wasn't just the click, it was actually the movement that seems to cause it. Now I'm going to go back here, put my cursor over that thing, and I see that CPU 16. That was CPU 16 interrupts. So let me try this again. I'm going to try to drive this up here. Okay, let's close that off. Let's go back to here. So there is an instats command. I'm going to go see what CPU 16 is doing. There's CPU 16. I see network interrupts coming in on it and local timer interrupts. So it looks like my CPU 16 is busy handling ETH0. I should do a T for a delta. So now I'm seeing not since boot, but what I'm doing live right now. So we're in the area of 2 or 3 interrupts there. I'm just going to scroll down. Again, these would be a normal, 250 is normal. And that's the only thing I'm able to see is the network traffic or those interrupts coming in. The cat/proc, no, let me grep. Grep for 16 in /proc/interrupts. See if I can find it here. Actually, I'm just getting the CPU number 16. I don't care about that. That's not what I wanted. Let me go back here for instats. I'm trying to get the IRQ here on CPU 16. And the IRQ is 137. That's where the interrupts are coming in on. So now let me grep 137 in /proc/interrupts. And there we can see the interrupts coming in. I'm not going to count them over, but this would be CPU 0, 1, 2, 3, 4, 5, 6, 12. Well, anyway, I'd have to count them more accurately. 1, 2, 3, 4, 5, 6, 7. So that looks like CPU 16 there. I want to do something else, topology-IO-affinity-V. And CPU 16 right there. And we can see a high number of interrupts coming in on it. Okay. So I was just using some different tools, and again with mpvis, that can take a long time to start up sometimes, --V, pipe it into TEE and call it mpvis.scene, for example. And then everything that was used to create that scene is now in this ASCII file. And then that can be fed into pmgsys. Okay, let me get back to pmchart now. I'm going to open view. These are predefined views. Notice I've already got the host pointing to Floyd 1. This will be in your labs for live tools, but I'm going to select CPU and open. And now I can see my CPU utilization. We've been doing this a couple of times. And it looks like I've got maybe 15% system time there from that. I'm not sure why we're seeing different numbers here. Because there I'm seeing 3%, 4% system time. Let me get back into the foreground there. Let me see if I can enlarge this. So for some reason, and I don't know why, I'm still seeing more than 10% system time here in a percentage. And that shouldn't be. Okay, let me close the chart and do this again now. So I'm going to do an open view, pick CPU first. Then I'm going to file open view I want swap. There it is, swap used. And now this time, this is my personal preference, but I'm going to create my own chart of memory. I'm going to say new chart. And again, this is all personal preference. One of the things I'm trying to do is replicate what Grossview did in IRIX and basically build a memory utilization stack bar chart. So I am going to start off with, and again, this is all personal preference, but I'm going to start off with page tables. Add that in. Then I'm going to add in the slab. Oh, where is it? There it is. The slab is the kernel heat. Oops, that's not what I wanted. Do an X to get rid of it. Slab, left arrow to add it in here. Then I'm going to do my dirty data that's being written. And by the way, well, we'll get to it here. After dirty is write back. Data that has been marked to flush but has not flushed off of memory yet. And then NFS unstable if it is going to an NFS server. And then from there it goes to cache clean. Now again, cache clean is a PCP derived metric. Now I'm going to do a non-pages, which is my process space. Then I'm going to do mapped. And mapped includes the attached shared memory segments. And then I'm going to do free. Okay, now I don't exactly like these colors. That's all personal preference again. But I'm going to try to change some of the colors and get a different color scheme going here. Try to do cache clean as like a, trying to pick a good color here. Trying to get it like this. And then I want free to be green. Let me make it a bright green. And in non-pages, I'm going to make it dark blue. So I was just trying to get, I kind of like free to be green. Actually, let me flip these around as well. I kind of like the slab to be yellow, even though page tables are yellow as well. And then dirty. Slab and page tables being added together are fine with me, but dirty I wanted to get to a red. Again, this is all just personal preference on how I like my colors. But reds are warning to me, and greens are good for me. Now I'm also going to go back here to chart and put in a title. And apply. Now I deliberately made a mistake here, but I didn't want this into a line plot. Again, notice there's blue up here. If I say edit chart and look at it, it's the chart that was blue highlighted. So I click down here and notice it went blue, and now I'm going to edit that chart and turn this into a stack bar and apply. Now I can see that most of my memory, let's just click on this one here, most of my memory is slab. I also have cache clean and take out free, and everything else like in non-pages is hardly anything. My page tables are about 40 meg in size. So it's kind of nice to be able to click on these and get down into the noise and sort things out. So I'm now looking at virtual memory. Physical memory and physical swap is my virtual memory. Let me go on now. I'm going to open a disk view so I can see IOPS, IO operations going to disk. And I'm going to do a file system to see how my disk space full is. And one last one, I'm going to go here, I'm going to go with network. I'm going to go with net bytes. So I now have all these different things in one chart, but notice they're starting to get a little bit too small. I'm also, by the way, going to go in here and edit samples and be able to get a bigger window in my display. I like to call it the coarseness of the experiment. I don't like these lines to be too wide like it was before, too coarse of an experiment, and I don't like them too tight. This is about right for me. So now that I've got that display and it all looks okay, what do we have here? Is there something? I'm just wondering if we had something at 100% full. Not seeing it. We'll come back to that later. So now I'm going to take that view and save it. Notice where it's saving it, and again, I'm running on Floyd 4, so I'm just going to call this Floyd 1 all. And save it off. Any questions right now? Again, I got too much on this display, but I do want to be able to correlate things, so I'm going to add in a new tab. This one I'm going to call memory, so I can look at just memory in more detail. And then I'm going to do a open view. And this time I'm going to go to that predefined view. If you see these heads up here, these people, I'm going to click there. And there's the file that I just created. This is an ASCII file that I can go in and edit with VI or email to somebody that describes the charts. So I'm going to open that. And again, I just want one thing here. So I'm going to click on this and close the chart. I'm just doing different things to use this. It's memory utilization that I wanted. And now I'm going to add in a new chart. And this one I just want to add in shemem. So I can see how much shared memory I have. And apply. So if I'm happy with that, I'm now going to save that view. Call it Floyd 1-memory. And I see about 14 gig in shemem. I'm going to keep going here. I'm going to add another tab. Let's call this trims. And I'm going to look at K-swap D statistics with this one. So I want to new chart. And this time I'm going to go into mem, vmstat. And then I've got a whole bunch of statistics that have to do with trims and stuff. Let me just see what these are going to do. Add them in. I really don't know which ones I want to begin with, so I've got to select a bunch of them and then filter them down. Page steals, I want that one. Pages being freed, let's get that one. And then page scans is where K-swap D is actually trying to find memory. When we run out of memory, find where it can trim. And also page steals, let me add those in. Again, I'm just piling everything into one chart, and then I can filter them out later. Some of them are not going to have anything going on in them. Okay, let me apply that. And also I want to go into mem, vmstat, This time I'm going to deal with allocations. Let's see. These NRs, by the way, are number of pages rather than kbytes like meminfo has. I'm just curious about that one. We'll stick it in there. Here's my page allocates. Really, it's just the underscore normal that we probably need. It depends upon the kernel that you're running. Page, I don't want activates or deactivates. Page ins, pages out. Page rotate is aging a page. Page freeze, steal. Oh, I should have added slab scanned here too, but let me get back to that. I wanted to have page freeze in here. I'm also going to throw in page deactivates and page activate. Again, the problem is that some of these are going to be 0 and some of them are going to be real big numbers. I want to get back to this one here and add to it, that's slabs. I had missed one, I think. There we are, slabs scanned, which is going to be relevant with what I'm going to do here in a minute. Apply. Oops, I got a new chart. I don't want that. So let me go to this one here, edit chart, and this is the one where I want to add in the new metric. And add it in there. By the way, I can see it's pretty much 0 here. Looking at this data, what is that one? I can click and find it out. K-swap D, skip congestion weight. Oh, no, that's something else burst on it. I got a real big spike here. And I don't know if I can find that one right off because I got too much on this particular chart. Let me just start taking things out to see if I can find it. A lot of these are not even going to have any statistics in them. I'm trying to find what that spike was, which, by the way, I can see down here as well. Page freeze. That's what it was. So we had a page free occur in there, which, by the way, is also down here, right there. Let me take page freeze out of this chart. Exit and get rid of it since I've got it elsewhere. And let me just try to get all this other stuff back in. So I'm not seeing any real trim activity. Down here, let me get rid of this page free and allocate. I can see a page allocation and a page. We should be able to see page activates too. I don't see anything there. Okay, so we're looking at K-swap D statistics. Now let me go on to another chart or another tab. Let's call this NUMA. I'm going to do a file, new chart, go to mem, NUMA, util, and I'm just going to look at free. Maybe I'll look at, I'll look at free. Now, I've only got 4 nodes here, so this isn't too bad. Put them in there and apply. And then I'm going to do another one, mem used. It's too messy to try to stack all the pieces of meminfo into one of these displays. So I'm only looking at free and used. Let's see, let's apply that. I'm going to do another one here now, mem, numa, util. I'm going to go with the slab. Apply that, and one more. Mem, numa, util, shemem. Okay, now these I'm not actually going to put a stack bar on because then it gets too hard to read. I just want to see where things are on a per node basis, not as an aggregate total. One more, file, new chart, no, add tab. Let's call this one NumaLink. And I'm going to open new chart and go to, in this case, I want to go to the UV group. We have a linkstat-UV that's been turned on with a -A. And the one I want is the NL for NumaLink. Again, the hubstats command allows me to switch to these other types of statistics, but I want traffic. And again, the send and receives are pretty much the same and mirror imaged. So I'm just going to do the send bytes. That's all I'm interested in. And then these are the ports that are within my cluster, but again, or within my partition. There are other ports there, but they're going to the other partitions. There's 4 ports per blade, and I'm only seeing 3 of the 4 ports because one of the ports is going off to the other partitions. Let me put that in there and apply. And I can see where my NumaLink traffic, again, we had some things that were in the 200 megabyte range and one that's in the 100 megabyte range. Okay, so now I'm going to save this stuff off. Save view, NumaLink. Save view, nodeinfo, I'll call it. This one I'll call kswap, because I'm primarily looking at trims and memory management. Now I already have a memory one. Okay. By the way, it looks like the system time has gone away right now. Now, hang in there. In my directory then, .tcp, pmchart, this is where those scenes were being put. So I'm going to cat Floyd1-all. I'm just going to call it all right now. Then I'm going to cat splat memory into all. I'm going to append it. I'm going to put this together as a single configuration file. Cat kswapd, cat nodeinfo, cat nl. Okay, so now I'm going to edit all, and in front of each of these charts, I can then put what my tab title is. So I put in a tab. I'm going to call this all. And I find my next plot, but I have to get rid of the stuff up in front. Get rid of this stuff. Open, tab, mem info, we'll call that thing. Then my next section. You can see you can mail this whole thing to somebody and have them use it. And this was my tab kswapd. And in the end, I already know some of these are not going to be relevant. Only the normal is relevant, so let me take rid of the DMAs and the highs and only use the normals right now. Okay. This was the nodeinfo tab. Oops. What did I do here? I don't know if I lost something here. Tab, pneumolink. Yeah, this is my nodeinfo. Tab, nodeinfo. And then pneumolink was my last one. Okay. So now I'm just going to try that thing, pmchart-h on Floyd 1. I'm going to find that thing, open view, click on the heads here, and there they all are, and the one that I just created was called all. Let me select that one and open it, and now I've got everything. My meminfo, my K-swap looks good, the node info on a per node basis, and the pneumolink traffic. Everyone with me? Any questions right now? So now I don't have to go through the creation of the charts. It's all pre-built for me. So again, our main problem, let's just bring this up again. Let me get out of here. Bring up top. So again, I still have about 6% system time. No, nothing else really showing up there. Most of my memory is used. I've got 6 gig that's still free. All my swap is used, nothing out there. Again, I have about 9 gig in my cache field and 61 meg in buffers. So one of the first things I'm going to try here is a BC free-A, which is going to trim the page cache of anything that is inactive or reclaimable. Let me go to meminfo here. So I'm getting a stall out right now. Everything is stuck for the moment. There, I'm getting something. So we've dropped data right now. My workstation is okay, but what I'm getting from Floyd 1 is not. Let me try going into Floyd 1. There we are. We're dropping data. Nothing's coming out of it. I can't log in. There we are. The event is now done. And we actually dropped data during that whole event. I wonder if I can catch anything there. Well, we do see some disk activity at the end of it and some network traffic at the end of it. See if we can catch anything else. And there was some, that one. Slab scans. So it looks like it was stalled out for some scanning of the slabs, which is kind of expected since I have a large slab still. Let me do a cat/proc/meminfo. So that stutter appeared to be a trim of the slab, enough to get memory back on the particular node that I was logging in on. And I don't know if we can spot it here. Not able to see any sort of actual change in the size of the slab on any of the 4 nodes. But I have to warn you, I've already lost the data that I'm interested in is already off screen. One of the things I didn't do here, I lost the number of samples. Let me get that back to where I was so the next time I've got something to look at. Okay, so we do have that gap that was in there now. I'm looking for a trim there. We are able to see the trims that occurred here, going through the slab, pages being deactivated, and then slabs that were scanned. And they went through, looked like about 30,000 slab entries that were scanned through. In fact, I've got it up here. Let me edit that chart and take that thing out, slab scan. Since I've got it on its own little display here, delete it. Okay, nodeinfo. Again, I didn't see any real trim going on there, but we definitely had a K-swap-D come in and try to do some trims. And there was actually interconnect traffic during that as well. We got rather high. So this would be a bad thing. Part of what was going on there was during that slab trim, my pneumo link got hot, particularly the blade 0, port 0. And also blade 0, and what's this green one? That one's blade 1, and that one's blade 1. Those are probably the same ports. So one of the things I suspect during that stutter here was the interconnect got busy, contention on the interconnect itself. And again, we also had a slab trim, but I don't see any effect on the slab here. Let me just see if I can catch that. Probably can't. Just trying to get down to the slab. I can't even see any sort of change in the slab there. So we did get some sort of slab scan from K-swap-D to try to recover memory, but we're not able to see it recover enough. Any questions right now? So notice again, my shemem is rather large at 14 gig. So I'm going to do an IPCS-AM, and I do have a 9 gig slab or 9 gig shemem there, and then an LS-L on dev shemem. Notice that this one is unattached, and I have a couple of ones here that are in the tempfs file system. So let me start off with this one up here, IPCRM-M. on this ID here. And that should reduce some of my shared memory, and we can see it actually going down from 14 gig down to about 7 gig now. So even though that said 9 gig, it looked like it really only had about 7 gig there. Let's see if we can catch that. A little bit of system time there, and actually some of that shemem was out on swap, so we see some swap space that was recovered. And we can see down here where some of the cached field, let me go back here, some of this cached field got trimmed because, again, shemem is in the cached field. Not seeing any trims or anything like that. That was just a removal. And I do see memory got freed up. It was across all 4 nodes. So I got a little bit more free memory from that. And we can see shemem here went down. Now I'm going to go into dev shemem. First of all, LSOF, let's grep for dev/shemem. I see dev shemem open by a shell and a grep and an ls, basically everything that I'm running in my current working directory. Let me get out of there and do that. So that was just showing when I CD'd into dev shemem that I had things open in there, and it was my current working directory for the shell, LSOF, grep. It looks like LSOS spawned a child here as well. Okay, so now I'm going to, nothing's open there. Let me also do an LSOF and grep for big file. Nothing there. So, dev shemem, let me remove those. We'll start off with big file. That one's gone. Let me remove the other one here, and then remove this one here. And now when I go back to meminfo, I can see that my shmem is now down in the 0 range. I can see my swap is also cleared up. All that unattached shared memory segment that was a memory leak was what was filling up my swap as well. And by the way, I haven't talked about this yet, but *W will tell me if there is any swap IO. And we did, *big W, sorry. And we did not have any actual swap IO. We had stuff allocated out on swap. There was one trickle swap in here, one burst, but other than that, even though my swap was full, none of it was actually being used. So there was no swap IO going on. But I still have a large slab. You can see the cache went down here. K-swap D, let's see if we can correlate here. So there was a trim there, and there was a trim there. And you can see them in K-swap D here with the green and page freeze. So those were the removal of the shared memory segments in dev shmem. And nodeinfo again showing me that I got most of my memory back and that shmem went down to nothing. And let's see if the Numalink traffic changed. We still have very high Numalink traffic right now. So we're still in the 250 megabyte range. I'm not sure if I can catch a correlation here. There was a correlation. This one and this one seems to correlate with this one and this one. So during that trim, it looks like the interconnect traffic actually went down during the removal of those dev shmem files. But we still have a lot of traffic going on there. And here I can see that dev shmem release. Let me get back. I still have a big slab, but I can see a little bit there and a little bit there. And notice also during this trimming, my system time went down, but now it's back up again. I never did find what that was, perf top. It's that raw spin lock, but I never found out what actually was calling the raw spin lock. I need to get into a profiling or something on a per process basis. I wonder, ps-e, grep for K-swap. Let's do a perf top-p on 144, for example, and see if we can catch anything there. Again, it does not appear to be running right now. It's sleeping right now, so that is not the system time. What else do we have here? Trying to catch what that system time is. These K-worker threads don't last very long. Didn't like it. Okay, so I'm kind of cleaning up here. I still have a 75 gig cached field here. What is that 75 gig? Give you a minute to figure it out because I warned you. I'm going to cat/proc/meminfo. And this cache field here is only 36 gig, or 36 meg, I mean. So remember, top is adding slab reclaimable in there. And if you take a look at this, that's what's in the top field. So I'm going to do something here now. Let me start my recorder and then push that slab down and see how long it takes to push the slab down. Okay, so I'm now recording the data here. It told me where I was recording it. Let me get out of here. cd into .pcp, pmlogger, then there will be, oops, wrong directory. Let me get up one. Then you've got the host name. And there's the archive file that I'm recording right now. Let me try a watch ls-l. And you can see that this file is growing. So I can play this file back later. Unfortunately, it's only recording, I'm not sure, it should be recording the current tab that you were on. It's not recording all the tabs. Let me do another one here and see what happens if I do a record on this one. And again, it's giving me host name, date, and all that sort of thing. Now I'm recording just that display. So now let me get everything back in. So I do see that 90 gig of my memory is the slab. So now it's the fun part. How long and can I push it down? And I've got a top running here as well. Let's see. Let me get top running here. So a lot of that system time is still these K-worker threads. I don't know of an easy way to look at them because they go away real quickly. You can see the PIDs are constantly changing. Okay, so memhog is a command that is standard Linux in the NumaCTL RPM, and I'm just going to fire off a bunch of them. Oops, I want to redirect standard out so that I don't have noise. And let me fire off, oops, doesn't like my syntax. Let me fire off a bunch of these. The question is, how long does it take to get memory back and trim this stuff? Okay, better double check here. I am on Floyd 1. I was expecting to see those memhogs by now. PS- oh, I'm on Floyd 4, that's why. Wrong one. So when I run out of memory on a node, the first thing it's going to do is try to trim the slab, and that's what we're doing here right now. I'm just firing some stuff off. EC-free is an SGI tool that will try to recover memory, and if you're not root, it will use memhog to do that. PS-EL, oops, just PS-L. And I can see most of these memhogs are running. I am able to see them in here. I'm going to do a top sys. And these things are growing in memory. Most of that CPU time should be system time. Let's see if we can catch it here. There we are. All that system time is going to be from the allocation of these pages. Let me break out of there and do a perf top. We still see that raw spin lock, particularly this one at 88%. And I still see some inode stuff in there as well. I'm not actually seeing the creation of these pages as these things are growing. Basically, your memory growth is locked on a per node basis. Only one processor thread can grow at a time. And I am still seeing some XFS data thing going on here. I'm trying to push the slab down, remember. Let's see if we're getting anything going on here. Page freeze, page allocates. I'm not even seeing any slabs being scanned yet. See if I can do another one here. I'm waiting to see that slab get pushed down or trimmed. And things are not looking good for me. I would have expected, everything is basically stuck on this system time. I don't know if I can catch this with a crash command either, but they're running, not sleeping. Perf top is my only real choice here. Notice my top sys, I can't even get my response right now. Let's see if I can log in. PCP is still running, but I'm able to get in that way easy enough. Let's see. PS-E, rep for memhog. Okay, I'm going to do a perf top -P. Let's just pick one, 28710. And again, the only thing that's doing is sitting there in raw spin lock. Oh, we have an isolate migrate pages. So everything's just spinning on this thing. That's what all that system time is. Let me try a GDB. And then look at the backtrace. At some point, this is all going to have the memory allocated. And then that system time will go away as it goes into something else. Computational work, for example. Still having trouble connecting to that thing. TopSys isn't even running yet. It can't get anything right now. See if we can spot anything else here. Slab isn't trimming at all, and my processes aren't growing at all. That's what's kind of surprising to me is that the, let me get rid of the slab, that my non-pages is not growing very well. I'm wondering about affinity or something. Not seeing a whole lot there in terms of slabs being scanned. Nodeinfo, a little bit of free went away as I ran it, but nothing really relevant there. And my Numalink traffic, other than a burst there, is still in the 300 megabyte range. So this system is kind of stalled out right now. I want to take a look at this later. I'm going to SSH to Floyd1 here. And I'm going to do an echo. Let me just try a W into /proc/sysrq-trigger. So this will give me a trace back on just the processes that are waiting. I can also do an echo T into proc/sysrq-trigger. And now if I do a D message and tail it, the kernel is now writing a trace back out. I'm still not even able to connect to that process. Still all system time, all that spin, raw spin, IRQ one. Nothing on swap. Little bit of disk activity, right? Notice there's a burst of reads going on right now, too. That should not be the D message or anything. See if we can catch anything else. So there is an increase here of these two. That's the page allocation. Oh, there we got our GDB now. Let me try a BT on that thing. And all we can see is that it is sitting in a memstat, SSE2. That's a particular type of instruction set. This program is not built with symbol tables, so we can't see the intermediate routines. But this is what's actually creating, zeroing out, allocating the page. And that more than likely is what's causing the spin IRQ that we're seeing in the high system time. Oh, system time has gone down now. Let's see. I did start getting some of this traceback information so we can see what's running. I'm more interested. Let me bring up top first. It looks like the memhog's just finished. Is that all I have is one memhog now? One memhog. So that wasn't very good. I wasn't able to get my slab pushed down at all. I'm not sure why right now. Let me cat/proc/$$ set. I'm in the global. Let me cat/proc/$$ and I am allowed on all CPUs and all memories. Let me try a memhog. Let me go 40 gig this time. I'm trying to push that slab down, and I wasn't getting it. Okay, so there's my system time again. Let me bring up top. There are all those memhogs running. Just out of curiosity, I want to go to wchan and make sure that's in there. And I can again see they're running and they have an R in them. And all that is this system time that we're seeing here. And then I'm watching the memory growth here. Let me try the perf top again. We're going to have to finish this experiment up pretty quickly here. There's raw spin lock IRQ and this IRQ save. Notice I'm not seeing any IRQ interrupt handler up here either. It's all system time that I'm seeing. And I'm still not seeing a push of the slab. This is not good. Let me try a memhog 100 gig and see what happens there. I'll go back to meminfo here. I'm trying to push down this huge slab, this 80 gig slab, and that's what I'm not seeing effective right now. Look at this memhog is just sitting there, not getting anything done. It's pure system time at this point. Let me do a ps-e-l prep for memhog. So there's the CPU time it's got already. Let's see here. I wanted to check affinity on it. cat/proc/$$ set. No, not there. I don't want $$. I want 31418. For the PID CPU set, it's in the global. I'm also going to check status. And that is allowed across all the CPUs and everything. Let's bring up top. I'm looking for affinity right now and to see what CPU they're on. I'm going to go to F and then hit in a J for the CPU that they're running on. So I can see that they are kind of spread out across all the CPUs. I'm going to do a capital O option and then sort by the CPU. And then I'd be able to see what's on each CPU. But again, this is too long. I'm going to do a Shift W here. Come on, Shift W to write it. There it is. I'm going to quit out of there. Do a top. dash B to get batch because I want to see the whole thing, and it should be sorted by CPU number now. Dash N2, I need 2 samples to get a confidence interval and stable statistics. Let's put that into a file. And do more on that file and see if we've got it. So it is sorted by CPU number now. So I've got something on CPU 30. Let's grep that now. And I'm just sorting by CPU number to see if we've got multiple things on the same CPU. No real scheme here, 3130, 29, 0.765432, 2120. Skipped 19 for some reason. 18, 17, skipped another 16 and 15 and 14. And then we've got another one that's actually back on 31. Not sure why it didn't sort by that column then. Why am I getting it again? Huh. Oh, 2 samples, that's why. I ran it twice to get a confidence interval. So the second sample is what I'm seeing the second time around. But this thing's still not pushing anything down. Okay, I'm going to wrap up here. VC free dash F. And again, the F is going to force the slab to be trimmed. Now I'm going to recommend for your labs and stuff, you might want to reboot your system if you want, but right now, oops, wasn't able to get anything there. So we're dropping some kind of data here. This is going to stop the recorder too. Let's see if I can get a look at that system now. And one of the things I might do here now, I'm going to SSH root at Floyd-CMC, type it into T, and then a BC free hang. And then do my UVcon --clear --no cache on P1. Control right bracket S to steal it from my other session. Notice I get no response on the system. Should be very careful about what you do on the serial console. I'm just going to see if I'm on the serial console here. I suspect I am. If I do an escape shift KDB, nope, that's not a serial console. Let me try it here now. Escape shift KDB, and I've dropped into KDB now. So when I've got an apparent hang of the system, drop into KDB, I like to type in summary. And my slab is still real big at 90 gig. I'm not getting any trim going on there. And I do have, what do we got there? 18 gig of memory free, but everything is stuck on that trim. So what I'm going to do here is an arch KDB, and that's just going to dump everything out, including stack traces for each of these processes. And also something called sched debug. And then there's the processes. Oh, and I can see things going on in there. This is what I was trying to get with the echo of a T. So this is what engineering can use to find out what everything is sleeping on. And when this is all done, I'm just going to do a go. I'm running a little bit behind today with all the demos and demo time. I plan on wrapping up here now and letting you get to lab. But I've got one other thing that I needed to do, and that was PBS. in your workbook, the perf eval module. Trying to get my browser up here. Anyway, let's type go. You can, by the way, while you're in there, do kills and stuff like that, too. And now I've got a traceback showing what all these processes were sleeping on. And some of them are normal waits. Some of them are waiting for a clock tick to come. But I also saw a lot of waits on, I saw some page allocations and stuff, too. And also some XFS. Here was an example of, here's that down lock that I mentioned. That'll get counted as your load level. So this code 503 will show a WCHAN of XFS buff lock. And that will get counted as a load level because it's marked as the down lock. But it will not get counted as IO wait. So it looks like this thing was in the process of creating a directory and allocating it. And then it went to sleep trying to get memory to do the allocation. Trying to see if I can find anything else, but most of them are down locks. Okay, so that BC free is still taking forever. Let me see if I can get in any other way. See, that looks like the console that I was on. Control right bracket S to steal it. No response on the console yet. You see if this other console is working. Nothing available there either. So it kind of looks like it's deadlocked right now. So I think this is a point where we call it a day and let you get to labs. And I think this is this system will probably need to get rebooted to get into the labs right away. In fact, let me do that. Let me do an escape shift KDB. Wrong console. Let me go to the other one I had here. Escape shift KDB, dropped into KDB, and I'm just going to do a K dump. And then I've got a dump of whatever was going on with this system. So let me stop sharing, but I basically pushed it into a hung situation. So I'm going to give you a lab assignment of the live tools and the perf eval module. We haven't talked about perf eval, but get started on it, and we'll get back to it tomorrow morning. Hang on a second here. So labs 5 and 6. See if you can get PBS Pro installed. There are directions in Lab 6. And then we'll regroup tomorrow morning. Any questions on that?
I have one question. Just how are we supposed to get into the what's it called, VNC on the node we're on?
Yeah. What you might need to do is go to like DMZ server or Floyd 4 to get it. Let me take a look at it during break. I'll put in an x11.conf file for you and see if we can get all the VNC viewers working.
Okay.
Anything else?